Students, this is the Unit 6 Study Guide, Peer Teach problem, problem number 7. Remember, when you are working and coaching this problem, you need to ask more questions than narrate answers. You should spend more time pestering your classmates than you should dictating to them. In other words, you want to create dialogue, not simply dictate answers. Before you can work this problem through, it's important you get out your study guide and find this section, proofs on a coordinate plane. Proofs on a coordinate plane. How to prove things on a coordinate plane. In a coordinate plane, you're working with the midpoint, slope, and distance. The midpoint equation is going to show if something is bisected or has a common midpoint. Write the midpoint equation in the margin. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2. The slope equation is going to show how a line tilts. Parallel lines, just as a recap, slope equals slope. And perpendicular lines, slope times slope equals -1. Let's write out the slope equation. Slope equals rise over run. Rise, you subtract the y's, over run, you subtract the x's. The distance equation shows comparison or comparative of lengths. It can show that two lengths are equal in measure or congruent. Write out the distance equation. Distance equals giant square root x minus x squared plus y minus y squared. So here's a common example. If you want to prove that ABCD is a parallelogram, you want to prove it's a parallelogram and you want to use midpoint, slope, or distance, let's go through the OCD qualities. The first O is opposite sides parallel. Second O is opposite sides equal. Third O, opposite sides congruent. C is consecutive angles are supplementary. And last one, diagonals bisect. Midpoint, slope, and distance cannot help us with opposite angles being congruent. And it can't help us to show that consecutive angles are supplementary. But the other three we can use. For example, if I want to show that opposite sides are parallel, I want to show those are parallel and those are parallel, we would use the slope equation because slope shows tilt. And I would do the slope equation 4 times. If I wanted to show that opposite sides were congruent in length to show it's a parallelogram, that would be the second one. Then I would do distance and distance, distance and distance to show that opposite sides were equal. I would have to do the distance equation, and I'd have to do it 4 times. This last one, if I wanted to show it's a parallelogram by the diagonals bisecting, I need to draw on the diagonals here, like AC and DB. And if I want to show that is the midpoint going both ways, I'd find the midpoint of AC, the midpoint of BD, so I would use midpoint for the diagonals, and I only have to do that 2 times. And I get the midpoint the same going both ways. Last way I could prove it's a parallelogram, if the same set of sides were both congruent and parallel. So for example, if I found the slope of these two and showed that they're parallel, and then if I showed the length of these two were also congruent by distance, then it's a parallelogram. So by using a combination of midpoint, slope, and distance, I have 4 different ways to prove that that's a parallelogram. So to this problem that you're actually teaching, it says right here, given FGHI is a quadrilateral, we're trying to prove that FGHI is a parallelogram, but not a rectangle. So there's actually 2 things going on here. So we have to do 2 things. One, we have to prove that yes, it is a parallelogram, but no, it's not a rectangle. The process I take you through, you have to bring your classmates through. Unique qualities of a parallelogram. OCD. Let's write this out. Opposite sides parallel. Opposite sides congruent. Opposite angles congruent. Consecutive angles supplementary. Diagonals bisect. I only need to prove one of those. So to show opposite sides were parallel, I'd have to do all 4 sides, 1, 2, 3, 4, and to do that, I would use the slope equation 4 times, all 4 sides. If I wanted to show that opposite sides were equal, I would do distance this way, distance that way. So I would have to do the distance equation 4 times to show that opposite sides were equal. I can't show the angles being equal or consecutive angles add up to 180 on a coordinate plane, but I could show the diagonals. If you drew in the diagonals, I could show the diagonals bisect each other by finding the midpoint of each diagonal. So to find the diagonals bisect, I would do the midpoint of the diagonals, of which there's only 2. So any one of these would be able to prove that yes, it's a parallelogram. But then we need to exclude the fact that it's a rectangle. So we have to ask ourselves, what are some unique qualities of a rectangle? In other words, what makes a rectangle different from a parallelogram, a basic parallelogram? So here's a parallelogram, here's a rectangle. And there's 2 main qualities. One is that, of course, we have 4 right angles in the corner. 2, the diagonal lengths in a rectangle have the same length. So the diagonal lengths are congruent. Using midpoint, slope, or distance, I could disprove that there are right angles here by finding the slope and we would disprove that slope times slope equals -1, which means there's no right angles. But in order to prove that there is not right angles, we'd have to do the slope of all four sides. Now, you could use slope to show that they're parallel, but then the same slope could show you that they are not perpendicular. And if you use the slope and they're not perpendicular, then you can say it's not a rectangle. Or if you draw in and you find the length of the diagonals using the distance equation, twice, you could prove it's not a rectangle. So you could use a distance equation twice. Now, when you coach this, help your classmates brainstorm this all by themselves and realize their options here. I'm not going to actually do the math for you, and you're not going to do the math for them. But their choices are this. In order to prove that, yes, it's a parallelogram, they could show opposite sides are parallel by doing the slope times 4. Opposite sides are congruent by doing distance times 4 on the side. Or the fact that the diagonals bisect each other by doing midpoint twice. So they have to choose one of these to prove that, yes, it's a parallelogram. But then to disprove that it's a rectangle, their choices are this. Slope again times 4 and show that they're not perpendicular, therefore it can't be a rectangle. Or the diagonal lengths, find them, and if the diagonal lengths are not congruent, it is not a rectangle. So they must choose one of this. So one of this and one of that in order to prove that, yes, it is a parallelogram, but no, it is not a rectangle. Your classmates will have to choose which attack they use, just help them to see their options.